Okay, today is a review day, and I'm going to mostly talk about some word problems, maybe a little bit of limits and that kind of stuff. Then your assignment for tonight is posted on Schoology, and it's like a practice quiz. I hope to, and should be able, hopefully, to get a key posted for you by the end of the day also, so that you can be looking at problems and answers and kind of know what you could be studying over the weekend. If there's topics you don't understand, you can always go back and watch these videos to get them. All right, so let's first talk. Imagine for a moment you went to Costco and you had this picture that you'd taken in landscape view, and it was 30 inches long by 10 inches high. And now the question is, let's say that you were going to put a frame around it. So now it's not going to be 30 inches by 10 inches anymore. It depends on how big the frame is. So if you were going to write an equation for this, you might say, but I need to know how big the frame is. No, you don't. You just need to use X for how wide the frame is, because you don't know how wide it is. It's just a board that you found in the basement, and like this one that you see here, maybe it's like 2.5 inches like this one, or don't know how wide it is, so we call it X. I'd like you to write two equations, one for the perimeter of this in terms of X, and one for the area in terms of X. And just to clarify, an answer that is in terms of X might look like this, 2X plus 3X or something like that. That is not the correct answer for the perimeter. I always suggest kids start with the main, like the general vanilla formula for perimeter, if you know it in terms of length and width. Okay, and then the normal for area, I hope you all know that's length times width. And then underneath that, stick in what we know for this problem. You should be able to write an answer for me for the perimeter and the area in terms of X, meaning that there's an X in your answer. I'll pause while you give that a shot. Okay, here's what you should have been thinking. Well, I don't know how wide X is, and if all you do is put an X, you'll probably fall susceptible or fall prey to the trap of saying it's 30 plus X, because it's not. Perimeter is 2 lengths plus 2 widths. And in this case, the length is not 30. It's 30 plus what? 2X. Because there's an X here and there's an X there. 30 plus 2X. Plus 2 times the width. And the width in this case is not 10, and it's not 10 plus X. It's what? 10 plus 2X. There we go. There's an expression in terms of X for the perimeter. How about the area of this guy? No. The area is length times width. Well, we already know the length and we already know the width. That's the length, that's the width. So area is 30 plus 2X times 10 plus 2X. Would you agree that when you multiply that out, you're going to get something with an X squared in it? Now I want you to think about the sketch of that then. And why does this make sense that as the X goes up, the area of the whole thing goes up? If X gets bigger, the area keeps getting bigger. See what I'm saying? Does it make sense that as the frame gets wider, the area gets bigger? That makes sense. All right. Then I want you to write for me what is the domain for X. What domain means what can I feed into X and have it work? Because there are things you could feed into X that wouldn't work and wouldn't make sense. What's the domain for X? Sir, you have no limit on yours. And you're right, because I never said there was a limit on how big X could be, right? A frame could be 12 inches wide. I want it to be. So there is no limit. Good. It could be ridiculously wide. It would make the picture look silly, but all right. Yes.
Would brackets 0, infinity, and
This is written. This means the exact same thing as that. Yes. This would be an interval notation. All right. Now, what if you had been told by a friend, you know what, you better not make it wider than 5 inches because I work at an art shop and they always say if frames get bigger than 5 inches, they start to look ridiculous. Then you could probably say it would be between 0 and 5. Okay. Now I'm going to give you another aspect to this problem, and I'm just going to say it in words, and I'm hoping that you will be able to translate that into an actual answer. Imagine that I had a ribbon in my family that had been through the Civil War. And the ribbon was held in the pocket of the soldier. He held it to remember his wife who had given him the ribbon. It's easy to carry, doesn't like slow you down, it's just stuffed in your pocket. And that ribbon, let's say that it is 100 inches long. Okay. If I want to wrap that around this frame, because let's say the frame is a picture of like the whole family, and like this ribbon, you know, is something, the oldest thing the family owns or whatever. So let's say I was going to put a ribbon around it that has 100 inches. And I didn't want to cut the ribbon because, you know, I wanted it to be, you know, I didn't want to lose that piece of history. So it's 100 inches all the way around. And so now, what is the maximum area that I could have for this whole thing? The picture's already got its area. The picture's area is 30 times 10 is 300. Question is, what's the area of the whole thing, including the frame? What's the maximum area I could have? I can make X any size I want, except I can't make it too big or my ribbon won't fit perfectly all the way around it. Think about where you should put that new information about the ribbon so that you could solve and figure out the area you'd have. I want to pause for a minute. Let me piece this together. So we came up with sticking in the 100 in for the perimeter, the 100-inch ribbon that's going around the outside of this frame. I apologize if I missed a second of this on the recording. We solved it down and figured out from right here, we came up with X must be, the frame must be 2.5 inches wide. And then when you stick the 2.5 in here and here, and actually multiply this all out, you get an area of 525 if we want that 80-inch ribbon to be able to go wrap perfectly around the outside of our frame. 100-inch ribbon, thank you. This one had an 80 in it, which is messing me up too. Okay, anyway. So that's an example of a type of word problems that we are kind of expecting at this point from you. Limit statements. Here is a sketch you can make. Make a sketch for like this situation. You got y equals x plus 3 squared, x minus 2, and then let's say just x to the third. I'm going to throw in a negative out front, and I want you to sketch what you think that would look like. Then, when you're done with it, you'll be able to write a limit statement for the right-hand side. Okay, so is it like that? No, it totally isn't, but make a sketch kind of like that. I'll pause while you give that one a shot. All right, so this has to bounce somewhere. Who knows where? Yes, sir? Hit bounce at -3 because there's a root at -3, and it's got a, what do you call that thing again? The multiplicity is 2. Very good. All right, so it's got to bounce there, but I can't tell which way it's going to bounce until later because I got to go and find the lead coefficient. How many of you took the time to go negative times x squared and x to the 1 and x to the 3rd makes x to the 6th, and it's negative x to the 6th. How many actually wrote that down somewhere? That was smart. You don't have to do it, but it's smart because sometimes we throw in weird things that are going to affect this, and if you go through and check your lead coefficient here, you might find it changes because you have an extra negative thrown in here or whatever. Okay, so you have a negative in front, which means down on the right, so it ends going down, and then it's got to be up on the left. True or false? False. Why would you say it has to be going down on the left then? Because it's an even. Even means the same, and so they're the same on each end. Okay, good. So now I've got to have a spot at 2, and I got to have a spot at, what the heck? What spot is that at? 0. Very good. Okay, so now I'm going to have it down here. And where was it bouncing again? I'm going to put a B for bouncing. It's bouncing there. Okay, so I'm going to go cut through, bounce. So, you don't think so? All right, explain. You have to snake through the origin. Very good. And I would not have counted this one. Now, if the kid had meant for that to be a snake, they should have labeled it as, like, that's a snake. But the way you're supposed to snake through it goes something like this. I'm cutting through here, and I would go and draw it like an x to the 3rd function, which goes like that. All right, and then I'm bouncing off of that and going back down again. It's also smart to find the y-intercept, but why don't I have to in this case? X equals 0. It's right there. That's the y-intercept. So I don't need to find it again. It's already there. All right. Good. That's a good sketch of this graph. Now, what's the limit on the right-hand side? Jill, what do you think? Limit, I got to read me the whole thing. Limit of, that's approaching.
On the right hand?
Yep. On the right hand, it would be x approaching infinity. And then it equals what? All right, I'm glad you're asking. So, limit of the function as x approaches infinity. All you've said here is I want to know the limit on the right. And I haven't actually got the limit yet. When I go forever this way, where is the y value? I already said x is way to the right. Where's the y value? Negative infinity. Because this is heading down. So if I go forever this way, it's going to be way down there. The answer is the y value would be at negative infinity. This is where your x value goes. This is where your y value goes. How many of you got that one right? I need to get a feeling for that. Okay. That's most people. Okay. So there's some good review. And that's not all of the things you need to know. I did a more thorough review and put it in a worksheet because we normally don't do this right before the test, but we don't have the test until Tuesday. And so I thought, I needed to have to do some practice here. So I made up some stuff and I sent it home with you on Schoology. If you find that document on Schoology, I hope to have a key posted later later tonight, actually. All right, so then the last thing for today. I think that's all I have for the video for today.